Hello viewers, I am Savitha Mary, Assistant Professor of Mathematics, St. Joseph College of Arts and Science, Kadalur. In this video, I am going to explain a problem using the method Newton's forward interpolation. Okay. In the previous video, we have discussed about the forward differences and interpolation, these all things. In this video, I am going to solve a problem and see the problem. The data are given. We are going to find the interpolate value 0.15. And what is a forward difference? Why do we use forward difference for this problem? Because the value 0.15 lies in between the value 0.1 and 0.2. 0.1 and 0.2 lies in the first part. When you split the data in the into two half, the first half is 0.1 and 0.2 and the middle value is 0.3 and the second half is 0.4 and 0.5. So the data 0.15 lies in between the values 0.1 and 0.2. So this is the first half of the given data. So we can use the forward difference formula for this problem. Okay, and for the first step we are going to see the formula. See the formula here, Newton's forward interpolation formula. So the value y naught and p del y naught. Here the value p is calculated by the formula x minus x naught divided by h. So we are finding the value p using the values x and x naught and h. Here x is the data which is we are going to find the value 0.15 is the value x and x naught is the initial value of the data which is in the first value in the tabular value, and h is the differences of the tabular value. So that is the differences of the x value. The common difference of the x value is mentioned by h. This is a general formula for n values. According to our data, we can change the formula values. And see our data representing x0, x1, x2, x3 and x4. So x4 four values are given. So we can rewrite the formula according to our data. And for the first step, we have to write the formula, and we are going to find the values p, y naught, del y naught, del squared y naught, del cube y naught and del 4 y naught. And see the table here, the forward difference table. I have mentioned the values here. X naught is 0.1, x1 is 0.2, x3 0.3, x4 x5 x4 values are there, and y naught, y1, y2, y3, y4 are there. And the first column representing the first differences. The first differences is calculated by the formula del y naught equal to y1 minus y naught. So the value of y1 is 10 point something and y naught is 20 point something, the topmost value. So subtracting the two values y1 minus y naught, we get the first difference del y naught. Likewise, subtracting the value y2 minus y1, y2 minus y1, we get del y1. And again continue this process, y3 minus y2, that is 5 minus 6, we get the value del y2. So you have to take care about the sign, the negative or positive signs. So then y4 minus y3, that is 4 point something minus 5 point something, we get minus 0 point something. So the calculation is mentioned in the table. So we can see first differences are calculated, and the second differences likewise, the second differences del squared y is calculated the same way, del y1 minus del y2, the reverse subtraction you have to follow, del y1 minus del y2. So del y1 value is minus 3.30802 and minus del y0, and again minus into again the value minus 9 point something. So minus into minus plus, so we'll get the positive value 6 point something. So you have to take care about the sign also, and continue this process likewise. We get the second differences, and next column third differences. Third differences is del squared y1 minus del squared y0 and del squared y2 minus del squared y1. We get the second third difference values, and the final differences we get 4 point something. This is the final difference, which is getted by the subtraction del cube y0 minus del cube y1, del cube y1 minus del cube y0. So we get the final difference. This is the complete forward difference table. So we complete the forward difference table. To write the values in the formula del y0, del squared y0, del cube y0, we have to select the values from the table. So I have highlighted the values. 0.1 is x0, y0 and del y0, del squared y0, del cube y0, del 4 y0. So you can follow the arrow. The topmost values in the table is for selected values, which is used to apply the formula, forward difference formula. And see the calculation here. This is the step 3. We have to calculate the values. First, the value x, the difference height, already told you height is nothing but the differences of x value. The differences of x value is the first value 0.1, second value 0.2. So subtracting the value, we get the differences of x is 0.1, which is h, and p is calculated by x minus x0 divided by h. X is the value which is mentioned in the question, that is we are going to calculate the interpolation value. 0.15 is the value x and 0.1 is the initial value, that is the topmost value in the table 0.1, and divided by h. P is equal to 0.5. We have calculated, at first we have to calculate the value p is equal to 0.5. Now apply the values in the formula. According to our table values, we need 5 terms: y0, p del y0, and del squared y0, del cube y0, del 4 y0. So I have converted the formula for our convenient way. So now apply the values in the formula. X value is 0.15 and y0 value, p value into del y0 value, then p into p minus 1 divided by 2 factorial, and so on. So calculating, applying the values, and the known values are there. So applying the known values using the table and also the calculated value of p and h, we can apply and solve the calculation, complete the calculation. We get the answer 13.7354714. This is the value, interpolating value. Okay, so the value of the dependent variable 0.15 is 13.7354714. And one more thing, we can verify the answer in the given data, and here the answer is 13 point something, and see the given table, the table value. Already I told you 0.15 lies in between the numbers 0.1 and 0.2. So 0.1 and 0.2, and they are dependent value of y is 20 and 10. So the answer 13 lies in between the number 20 and 10. It should be lies in between the number 20 and that is the y0 to y1. So your answer is 13. It lies in between the number. So it's a correct answer. You can verify the answer. It is correct. Okay. Thank you. I hope you are understand the concept, and in the next video we will see the backward differences of Newton's formula. Okay. Thank you, students. Thank you.